Welcome to the Podkey summary of what's new in image understanding from WWDC 2026. A lot of this week's Apple developer news comes down to one idea. Images are getting a lot more usable, a lot more interactive, and a lot less locked into one narrow workflow. Vision can now cut out objects with a tap and refine the result as you go. Foundation models can work directly from photos and prompts. And the two frameworks are starting to work together in a pretty practical way. There's also a nice little watchOS angle here, where even something as simple as smarter image cropping can make a tiny screen feel much more helpful. The headline feature on the Vision side is a new tap-to-segment API. Instead of being limited to the built-in person segmentation models, developers can now isolate basically any object in an image just by giving the system a point to tap on. That matters, because it turns segmentation into a much more general UI building block. Whether you're making an editor, a shopping app, an identification tool, or anything where the user wants to point at the thing they mean and get a clean mask back. The API returns a pixel buffer mask, so it drops pretty directly into existing image and interface pipelines. And it works across iPhone, iPad, and now watchOS 2, which is one of those quiet little expansions that opens up more interesting uses than you might expect. One practical note before the first request on a device, the segmentation model has to be downloaded with the Download Assets API, and developers can check whether it's ready with asset status. The nice part is that this is not a one-input system. Developers can define the target region with a single seed point, a bounding box, a lasso stroke, or a free-form scribble. Each one fits a slightly different kind of interaction. A quick tap is great when the object is obvious. A box is useful when you want to narrow the model's attention. And scribbles are especially handy because they can segment multiple objects at the same time. There's also a small but important implementation detail with the lasso. The stroke needs to be at least about 1% of the image width to reliably produce a good mask. That kind of note can save somebody an afternoon of wondering why their demo looked cursed. What makes this feel genuinely interactive is the refinement loop. After the first mask comes back, you can add more points to include missing regions or exclude parts you didn't want. So instead of throwing away the result and starting from scratch, the user can kind of steer the segmentation toward the right answer. Each update is done with a new generate iterative segmentation request that includes the extra points, and the system produces an updated mask from there. That sounds technical, but the user-facing effect is simple. Tap, adjust, tap again, and the cutout gets better. On the language model side, the big shift is that the Foundation Models framework now accepts image attachments in prompts. So a developer can send a single request that combines text instructions with an image reference using the prompt builder syntax and get back something grounded in the photo. The examples are very approachable too. One is straightforward caption generation, which shows the model doing the plain descriptive work you'd expect. Another is more creative, taking a picture of what's in your fridge and asking for a recipe. That second example is a good reminder that multimodal prompting is not just about recognition. It's also about turning what the model sees into something useful or fun or weirdly convenient at 6:30 p.m. There's a pretty clear trade-off between the two frameworks, and the source material makes the case without being too ideological about it. Vision APIs are fine-tuned for specific computer vision jobs, and they're fast enough for things like real-time video frame analysis. Foundation models are much more flexible, but they're slower. So the takeaway isn't that one replaces the other. It's that they serve different roles, and the best setup can be combining them. So you get the speed of task-specific vision tools and the broader reasoning of an LLM. That combination gets more concrete with tool calling, which now supports image arguments. An LLM can request a custom vision-based tool to inspect a photo and return structured results instead of trying to do every bit of image analysis itself. The model doesn't pass raw image bytes around. It passes an image reference, and the tool resolves that reference against the chat transcript to get the pixel buffer it needs. That setup is cleaner, and it makes the workflow feel much more native to how a multimodal assistant should behave. Apple is also shipping ready-made vision tools for barcode and QR reading, plus OCR. That means if the LLM hits an image with a lot of dense text or some scannable code, it can call out to a tool that's specifically better at that job. The OCR support covers more than 30 languages and is particularly strong on fine-grained or document-like text, which is exactly where general-purpose models can get sloppy. So this is one of those very practical quality improvements. Less guessing, more actually reading what's there. And if the built-in tools don't cover your use case, developers can make their own by conforming to the foundation model's tool protocol. You define the input arguments, including things like image reference, and then implement a call method that runs whatever vision analysis you want. The example here is a plant identification tool, which is a good illustration of the broader pattern. You can wrap a domain-specific vision workflow, expose it to the language model, and let the model decide when that tool is the right way to understand an image. That's a useful architecture because it keeps the LLM conversational and flexible, while letting specialized code do the heavy lifting where precision matters. The watchOS piece is smaller, but honestly pretty charming. Vision saliency analysis can be used to crop an image down to the most important region before showing it on Apple Watch, which is exactly the kind of thing that matters on a tiny display. The flow uses generate objectness-based saliency image request to get bounding boxes, picks the most prominent one, and crops the image before display. In the example, that makes a wildlife identification interface clearer because the subject of the photo gets center stage instead of being lost in a miniature full-frame image. It's a good reminder that computer vision is not always about dramatic AI tricks. Sometimes it's just about making the screen show the right thing. The common thread through all of this is that Apple's image tooling is getting more hands-on and more composable. You can segment, refine, prompt with photos, call specialized tools, and even make a watch app a little less squinty. That's a pretty solid week if your software has to look at the world and make sense of it. This episode was generated by Podkey. Create your own at podkey.fm.